Good day all. Imagine a situation where all sentences written in one language can be translated perfectly into another language, regardless of context or domain. While this may be the case between two high-resource language pairs, it is not the case with low-resource languages like the Hausa language. This is because of the insufficiency of parallel datasets for training translation systems in such languages. Consequently, when brainstorming our project ideas, we settled on providing a scalable solution to this problem. While manual creation of sufficient parallel data is a possible solution, it is extremely expensive and may be seen as not scalable. Therefore, our solution involves leveraging the Cohere multilingual embedding model to pair up sentences in one language with their potential pair translation in the target language. This way, a large translation dataset can be created using the existing large body of text that are available online. We specifically focus on Hausa to English translation since most of our team members are native Hausa speakers. The idea is to supply two files, source file and target file. The source file contains sentences in in Hausa language, and the target file contains sentences in English language, which are translations of the Hausa sentences. On this repo, we have script files with functions to implement the embedding, a few functions to implement the Cohere multilingual embedding model, and that for implementing LASA, which is serve as the baseline. We also have a notebook which can be used to test out the implementation. The notebook is to test the code. To use the repository, you could supply your own test and target files and get the result. So I have a Colab notebook open that I use to demonstrate the implementation. To test it out, you need to create a Cohere account and a Google account. The Cohere account is needed as an API key has to be supplied to use the Cohere API. So please get your Cohere and Google account and then you can run the notebook. To save some time, I have run the notebook already. We have code in these cells to mount your drive and clone the repo on your drive. The Colab notebook will ask for permission on your Google account. Please grant it. Change the directory of your file and then install Cohere here. After you install Cohere, you run this after supplying the API key, because without providing the API key here, the code will not run. Then we get the install the laser autoencoder model, and then we also run it to get the alignments done by laser. Let's quickly look at the results. Here, this is my drive. Then I navigate quickly to the name of the repository, Cohere Parallel Language Sentence Alignments. To see the translations under the Cohere folder, there is the Cohere translations, which are here. So we see they are mostly correct. So it's really accurate with the pairings. And then the laser translations, and lesser translations not so well. The next thing we did is to evaluate the model, and then we used the Flores dataset to evaluate the model, and then we use scaling. So for the same thing, we did the Cohere alignment and the lesser alignments for the on the Flores datasets, and then we calculated the F1 score. The outputs can be found on the Flores folder for the Cohere and lesser translations. I'm sure you'll be amazed by the performance of the Cohere translation. And we got an F1 score of 0.9496 for the Cohere, which is so excellent. The lesser model, on the other hand, did not do so well. The implementation is quite accurate and there are many potential use cases. After you clone on your drive, you could change the source and target files, open them up, the source and target, supply your own sentences, and it can pair them up for you and put them in the Cohere folder. So the implementation can be used, has so many potential use cases. We're looking at language learning apps and things like that. We're really grateful for the session where Louis demonstrated how embeddings work, and it's made us zero in on this idea. Thank you so much for watching.